Consider the following diagram. The blue circle's radius is 4 and the green circle's radius is 2. The line is tangent to all three circles and the three circles touch each other. They are pairwise tangent. What is the radius of the white circle? I thank Devin from Indonesia at the Lilin Bangsa Intercultural School for suggesting this problem. It was a challenge problem for students aged 14 and 15. Can you figure it out? Give this problem a try, and when you're ready, keep watching the video for a solution. So how can we solve this problem? Well, it will involve connecting the centers of these circles. The large circle has a radius of 4, the next largest circle has a radius of 2, and we'll label the third circle's radius as little r. Now we can create 3 different right triangles by connecting the centers of these circles. The first triangle will connect the center of this small circle to the center of the circle with radius of 4. This will be a right triangle. Its hypotenuse will be the sum of the 2 radii. It'll be 4 plus r. One of its legs will be the difference between 4 and r, so that'll be 4 minus r. The other leg of this triangle we can solve using the Pythagorean theorem. This will be the square root of the quantity 4 plus r squared minus the quantity 4 minus r squared. We can simplify this to be 4 times the square root of r. Now we can do a similar thing with the other circle that has a radius of 2. Its hypotenuse will be 2 plus r, one of its legs will be 2 minus r, and we can solve for the length of the other leg using the Pythagorean theorem. It'll be a similar calculation, and we'll get this as 2 times the square root of 2 multiplied by the square root of r. Now there's one more right triangle to consider. This will connect the centers of the 2 larger circles. The hypotenuse will be the sum of the radii. 4 plus 2 is equal to 6. One leg will be 4 minus 2, and that's equal to 2. Other leg is parallel to the 2 lengths at the bottom. So this will be square root of r times the quantity 4 plus 2 times the square root of 2. We can then use the Pythagorean theorem, and we'll get 6 squared minus 2 squared is equal to the square of this other leg. We can then do some algebra and simplify it, and now you're going to divide by 4 plus 2 times the square root of 2 squared. Now in order to simplify that, you can multiply the numerator and the denominator by 4 minus 2 times the square root of 2 squared. And you'll end up rationalizing this fraction, and you'll get that r is equal to 12 minus 8 times the square root of 2, and that's our answer. So that's our answer for these specific lengths. But can we generalize this? What would happen if our 2 larger circles had arbitrary values? Well, we can modify this diagram as follows. Suppose the largest circle has a radius of capital R1, and the next largest circle has a radius of capital R sub 2. We still have the following 3 triangles, and we can figure out the lengths of each of these sides as we just did before. The hypotenuse of each triangle will be the sum of the 2 radii. One leg will be the difference of the radii, and we can solve for the other leg using the Pythagorean theorem. In this case, we'll just label it as x1, and we could set up the following equation using the Pythagorean theorem. We'll do the same thing for the green triangle. We have x2 expressed using the Pythagorean theorem. And now, in this third triangle, which is in purple, we can solve for this leg as the sum of x1 plus x2, and we can also use the Pythagorean theorem. Now, with some effort, we can solve for r, little r that is, and we'll get the following equation. 1 divided by the square root of r is equal to 1 divided by the square root of r1 plus 1 divided by the square root of r2. And like magic, we figured out an equation that we can solve for little r regardless of the values of big R1 and big R2. Tremendous. Did you figure it out? And did you solve for this general relationship? Thanks for watching. These math videos, which can be watched for free, inspire and build confidence for people around the world, and they already have over 100 million views. Let's share the beauty of mathematics. With your help, we can math the world a better place.